Now we are starting with the new topic, functions. After relation we have function. Last year also we have done function. Basic I told you that I'll revise once more. A and B are two sets we have. Non-empty set we are taking in this case. Non-empty set means they should have at least one element. Then there must be a rule going from A to B denoted by F is said to be function if each and every element of set A should have association this side. There are certain element here also. Each element of this must associate first, means each element here should have the image here, and that image must be unique. Means, for example, this have the image here, 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 this the image here. So what you will find here, each and every element this side has the image, and that image must be unique. Then we will say yes, this will be a function. So function is nothing but a rule, or we call as correspondence, or we call as a mapping, which is associating each and every element of set A to the element of set B, and that association must be unique. For example, now we'll say we have elements 1, 2, 3. Here we have 2, 5, 7. Let 1 is associated with 2, 2 is associated with 5, 7, and this. Then my question is it a function or no? Just check. This has association this side, this has association this side, this has association this side. But problem is what? The association is compulsory, but at the same time that association must be unique also. Here what you will find, this 2 has association with 2 elements. That means it cannot be a function. By the way, it comes out to be this way. 1 is association with this, 2 and 3. Now what you will say, yes, it will be a function because each is associated this side and that association is unique. Don't say it is a double association, no. 1 is associated by only one element, 2. 2 is associated with 2. Maybe their images are coming same, but their association is a single element. 1 associate with 2, 2 associate with 2. So how many association with of 2? Only one element. How many association of 1? Only one element. How many association of 3? Only one element. So we will say yes, it will be a function, but it will not be a function. So that you should keep in mind, the association should be given such a way that each and every element this side should have the association, and that association should be unique. Then we will say this is the set A, this is set B, this will be the function denoted by F. Here we will say each element X. Then I told you it will be having association this side with a unique element, and that image which you will be having, that will be called F image of X denoted by Fx. This is called F image of X. So X is here, this is F image of X, this is we'll take as Y. So we will say every element, each and every element has the association this side, it is X, then this will be Fx, which we'll take as Y. So X, Fx. Now one more thing, first set we always call as domain. First set which we call as domain of the function. Second set I told earlier also, this is codomain. And then comes range. Range means the collection of images. This is collection of images. This will be called as the range of the function. So here in this case, domain will be always a first set, codomain will be the second set, and range will be the collection of images. For example, now I'll take one question on it here. Function is going from natural number to natural number. And we will say the function is denoted by this. Fx is x squared. Now check whether this f which is given gives a function or not. Here the elements come out to be 1, 2, 3, 4, 5, so on. Here also 1, 2, 3, 4, 5, 6, so on. When you put 1 image will be 1 square. So 1 will have the image 1. When you take the image of 2, it will be 2 square. So 2 will have image 4. 3 will have the image 9. Then 4 will have the image 16. So what you will find, each and every element has image this side. And here in this case, these images will be infinite, elements are infinite. So if I say what is domain of this function, that will be natural number. What is codomain of this function? We will say yes, it is a natural number. Then what will be the range? Range is the collection of images. What the images are? 1, 4, comes out to be 9, then 16, so on. This will be the range we have. So yes, it will be clearly a function because each and every element has the image this side and that image is coming unique. By the way, this function says function is going from integers to integers. And here we will say function is coming as modulus of x. Then what change will be here? First set will be the integers. Integers means it will be 0, minus 1, minus 2, minus 3, so on. It will come out to be plus 1, 2, 3, so on. Here also 0, minus 1, minus 2, so on. Then 1, 2, 3, so on. And this is the function we have. And fx is given as modulus x. Then we check again, is it a function or not? When you put it 0, the image come out to be 0. When you put it minus 1, the image come out to be 1. Plus 1 also have image 1. Minus 2 will have image 2. Plus 2 will have the image 2. Minus 3 have the image 9. Sorry, 3. 3 will have the image 3. Same way we will say in this case. So what is the domain of the function? Domain will be all the integers. Codomain of the function will be all the integers. But what should be the range this time? Each and every element has a unique image this side. And what will be the range? Range will be always a positive number, that is 0, 1, 2, 3, so on. So this will be the range we have. So domain of the function, codomain of the function, range, everything we have done. So these are the things we have done last year, and I told you function means that will be the rule which will associate each and every element of this set with this, and that association must come out to be unique. Now coming on kind of function which we have this year in our syllabus. Before that, one more thing you note here. If we have two functions f and g, f is a one function, g is another function, its domain is d1, its domain is d2, and going to r, this is also r. Now when you say add these two functions f plus g, then keep in mind this function will define from d1 intersection d2 to r. When you add two functions, when domain you will take, it will be the intersection of the two, and codomain remains same, and f plus g of x comes out to be simply fx plus gx. That you should keep in mind. Same way when you go for f minus of g, again d1 intersection d2 will be the new domain, and f minus g of x comes out to be fx minus of gx. Same way when you say f into g of x, sorry, f into g, again we say domain will be d1 intersection d2 to r, and then we will say f into g of x will be fx into gx. Then same way f by g, if you take, then it will come out to be d1 intersection d2 minus that x where gx is 0 to r, and then f by g of x will be fx by gx. These are the certain rules we should know, how to add two functions, how to subtract two functions. But keep in mind, whenever you are adding or subtracting or dividing or multiplying, then keep in mind the new domain will be the intersection of the two domains. Codomain is no problem, range automatically going to come according to the function. So that you should keep in mind. So this is also you should remember. Now coming on kind of functions. That is important now, and the question will come on these type of functions. That is kind of function. Kinds of function. In that first kind, which we have is any function you take, either it will be one function or it will be come out to be many one. Any function which you have will be called as one function or it is called as many one function. Example I am taking here. This is set A, this is set B. Elements are 1, 2, 3, 4, 2, 5, 7. This is the first example I have taken. Then another one is now check here. First, is it a function we should check? Here you will find each and every element here has image this side and that image is unique. 1 will have the image 2, 2 will have image 5, 3 will have image 5, 4 will have image 7. Here also it is a function, yes. This function I denoted by, let it is f1. This function I denoted by f2 and this function I'll take it f3. This is also function and this is also function because 1 have only one image, 2 will have only one image, 3 will have only one image, 4 will have only one image. Yes, it will say it will be a function. Now my question is, in what case the function said to be 1 and in what case it will be many 1. A function, in my simple words, if we'll say a function f is said to be 1 if each and every element of set A has image this side and that image does not coincide with other elements image. I'll just take a definition first, then it will be more clear. Yes, definition says of 1 different element of set A have different images in set B. It means 1 and 2 are different element. Their images in this will be different. 2 and 3 are different. Their images should be different. Here in this case, what you will find, 2 is not equal to 3. But what I am finding, the elements are different, but their images are same. Let's check here. That means it will not be 1. It is not one function because I told you different element of set A. In set A, whatever different elements are there, all different elements should have the different images. Here in this case, what you will find, any two element you take, 1 and 2 different element, their images are different. 2 and 3 are different element, their images are different. 3 and 4 are different element, their images are different. No two element have the same image. We will say yes, it will be one function. Because different element here, different images. Here what you will find, these are different elements, but their images are same. So we will say it is not 1 means it is called many 1. Many 1 means different element, at least two different elements should have the same image. Here in this case, what you will find, three different elements have the same image, so we'll say many 1, not 1. In this case, two different elements have the same image, we'll say it will be many 1. So any function which is not 1 automatically come out to be many 1. So we will say a function is said to be 1 if different element of set A has different images in set B. It means now in general what I can say, if the function is 1, mathematically what you will write, if the function is 1, if f is 1 from A to B, then what first condition says, then it condition says, then A not equal to B. Means two elements which are not same implies FA not equal to FB. If two elements are not equal, their images should not be equal. If two elements are different, A and B are not equal, means they are different, their images are also coming different. We will say, yes, this function is said to be 1, 1. Another case we can say, this is the first definition we have. Or you can prove this way. Second condition says, it says if I say FA is equal to FB. Two elements I am taking. Two elements A and B. By the way, if I say they are equal, this is 5, then 5 is equal to 5. So we will say if two elements are having the same image. Here in this case, two elements have the same image. That is, FA is coming equal to FB. FA is equal to FB. This is element of 2 and 3, two images. So FA is equal to FB. If that implies A is equal to B, means by the way, this changes to 2 only. This is 2 again. I'll write it twice. What you will find? The image of A, image of B are same, and by the way, if I say this element is A, this is B. What I am finding here, this is equal to FA, this is coming out to be FB. And if FA is equal to FB is there, then A and B, if they are also coming equal, we will say 1, 1. If A and B are not equal, we will say it will be manual. So second condition says if FA is equal to FB, we have, this implies A is equal to B. Means if the images are same, the element has to be same, then we will say function is to be 1, 1. So this is the first condition, or this is the second condition we will say. Either you prove this, that different element have different images, or you prove that two elements in the codomain, if have the same image, the element has to be same, then we will say function is said to be 1. Next video will continue.